Okay, I'm talking about Linux ButterFS or BTRFS. Uh, my name is Anand Jain. I work for Oracle here in Singapore, and I also organize the Linux kernel meetup in Singapore. And those who are from Singapore can look forward to come to that meetup in Singapore. And previously I have worked for Solaris kernel, developed a couple of drivers and handled the IO layer, and also worked on the popular ZFS storage. Okay, now coming to the Linux BTRFS. I think everyone knows the background of BTRFS, I believe, right? And so I will not go too much in depth about it, but the idea behind BTRFS is to have a feature rich, to have all the advanced features. Like the industry learned a lot of things by previous file systems like ZFS and WAFL, and this kind of file systems showed us like what a file systems could do potentially, and which in those days any other file system wasn't doing it. So that was a good opportunity to bring something to Linux file system, and that's where the BTRFS is. So coming to the features. So once you are using BTRFS, then you don't have to use the LVM or MD or any pool managers, because it has inbuilt pool manager. And then how do we do it in terms of the striping, in terms of mirroring? It's all done at the object level from the file system. So file system can handle it much more efficiently rather than being handled at the LVM layer. And since we can manage things more efficiently, like we can let the group profiles to change on the fly, still when the applications is still using the file system. So you don't have to like unmount the file system, even unmount the file system to change the group profiles on the devices. So like you can have a different group profiles for the metadata and data completely, and like the group profiles, it supports all the popular profiles like RAID 0 to 6 and 10 duplications and everything. And
parity RAID now?
Sorry, yes, it does RAID 5.
Yeah, what years?
That was recently introduced some time back last year. And the BTRFS is a copy and write file system. It doesn't modify the content as such without copying it. It copies the content, modifies it, and writes it in a different location. And this is called copy on write technology. And by this, like what we can ensure is that the file system is never inconsistent. One of the primary problem with the file system is that all of a sudden, if it power shutdowns, and you will have your file system left in an inconsistent state, and that would let not to mount the file system at all. So this kind of issues would not happen in BTRFS. But as of now, the implementation has some challenges. It's not yet there, but eventually we would hope that it will reach there. And ZFS did it very successfully, and that's the reason there is no FSCK for ZFS as such. Since one of the primary reasons that we wanted this BTRFS is the fault tolerance and the data protection. Data protection is very, very, very important for any enterprise file system. In those days when ZFS was born, like the hardware was not that matured enough as we have now, and silent data corruptions were quite common. and the file system and the operating systems would not have any aware like who, what, when happened things. And the data corruptions are very critical. We can't ask the users or the customers or the end businesses to reproduce the problem. So, these kind of file systems handles the data corruptions very transparently, to implement that, we have the data and metadata checksumming done within the file system. It saves the checksum of both data and metadata. Whenever the block is read, and if the checksum doesn't match, then mostly the silent data corruption has happened. And what does the BTRFS do is to take the good data from the other group profile. If it is RAID 1, then try to write the good data on the bad location, on the bad corrupted data, then make a log in the kernel log. And with this, the application is not aware that there was such a corruption happened, and it automatically recovered from it. Okay, one of the design principles that we employed in designing BTRFS is to make the configuration and administration of the file system and the underlying devices very smooth and very simple. And there is only one command to run to manage your pool and the file system altogether. That is the BTRFS. However, to create a file system, then you have to use MKFS. That's the only other command that we have. And once you create the file system, it can be easily mounted. And after that, if you decide that if you have more devices to add to it, then you can use any device add command and add another device. And later, if you change your mind that you want a different group profile, you are not happy with the RAID 0 or single group, then you can use the convert command to convert to RAID 1. And everything happens when you are still using the file system. Okay, since BTRFS is a binary tree file system, and one of the primary features what BTRFS provides is the snapshots of these trees. And tree manages both data and metadata of the file system. Each tree subvolume is a tree as such, and you can mount this tree file system independently of your the root file system. And each subvolume, these are called as subvolumes, and each subvolume can have properties set to it, particularly to it, and nothing else. Like you can have two subvolumes within a file system, and one of the subvolume you could say that I want compression on this subvolume, and you can create another subvolume and say I want an encryption instead of the compression on this. So those are very pretty useful features. And the snapshots are quite useful in case like if you want to go back in time, if you have a consistent snapshots at every point in time, like whenever you upgrade, you have a snapshot. Whenever you apply a patch, you have a snapshot. If you have these kind of snapshots, then you have a flexibility of going back if certain things doesn't work. Like you don't have to uninstall the packages. Instead, you can pick the file system which is old good enough and try to boot from that. And these snapshots are both, by default it is writable. However, you can create read-only snapshots. There is a purpose why you have to do that. You have to do that for the send and receive purpose. And send and receive is a really cool feature. Like remote replication is a very common feature in enterprise data centers. And the data centers do take the remote backup at different locations. So, and these locations are all connected through the internet. And what we have is like we have you could take a snapshot of your file system, and you can find the diff. You can take the diff of that file system and send it across the internet to your remote server, and there you can apply that diff on the local BTRFS file system, and there that way you can take an incremental backup over a period of time. This works more efficiently than having an rsync. rsync could do this as well, but this works much simpler and much better than the rsync because you are taking a diff at the block level, not at the files level. Here is a simple example to show how things could be as simple as a few commands. So basically the first command is to create a subvolume, and the second is like you take a snapshot of your home directory for backup, and the third one is like I'm giving an example of a snapshot with a read-only choice. Since it's a read-only snapshot, then here I use it to send the diff to a here I'm showing it for a local file system. However, you could write it to a file and send it to a remote server.
Question, so,
Yes.
so this doesn't allow for excluding stuff from the backup or only backing up a subdirectory or anything like that, right? It's all or nothing. Of the subvolume.
Correct.
Subvolume.
Subvolumes, yeah. Yeah. Subvolumes is nothing but a directory. I mean, it's as simple as that. But all the properties can be set exclusively for a subvolumes.
So you can create a subvolume for your 10. Like if it's got a scratch file for some application set, you can create that somewhere else and point to it. So it's not in a part of your snapshots every time, so you're not wasting time with that if you've got a program that's doing something. But the nice thing about this one is rsync, if it's doing 10 files, if the file changes, if it's at the 5th file and the 10th file changes, it's going to pick up that change because it's not a time-based, whereas these snapshots are time-based, so it's at that very instant, so it doesn't matter what happens after that you started it, it's at that time it was the copy. So if there's interdependencies between the files, like the two files get changed and they're related, you're going to get those two changes. If the second one changes in rsync, the second one can change, and the first one, but you've backed up the first one already, the second one you haven't got to yet, you've broken your app.
Correct. It's a point in time of a directory. It's as simple as that. But we can still...
Subvolume still can't have a different rate level, though, can they?
No, not yet.
Is that planned? That's planned, like, correct?
I'm not too sure about that.
I'm praying. It makes life a lot easier.
So is that useful? Is that useful?
Well, for, say you got a reasonably large server, so for my boot volumes, or my core volumes, I might want them RAID 10. But for my data volumes, I want them RAID 5. Because I just want the space, I don't care about it, I just want a little bit around. And then I just want to be able to do, so I've got everything stripped across 10 drives or something like that on my boot, so it doesn't matter what happens, I'm safe, booting. And then my data, at the moment I have to go and say, this little bit of space over here is one BTRFS by the better FS volume. And then I've got to go and create another one instead of creating subvolumes.
Yeah.
But having a more than one means I have a lot more flexibility. If I get rich and buy more hard drives and decide I want RAID 10 on my data too, then I can turn around and just switch it over.
Yeah, thanks for the feedback. And BTRFS is under heavy development. We are adding quite a lot of features, and anyone who has any good ideas about the features that they think is most useful could always write to us at the community, and we will sure consider it.
So speaking of what you can and cannot do for subvolume, so you mentioned that BTRFS is a full stack solution, shouldn't need LVM if you use it. So I would like nothing more than to not use LVM. ButterFS doesn't have a good story for encryption unless you encrypt the whole thing, right?
Yeah.
Can you do per subvolume encryption?
I'm coming to that.
Okay, cool.
You're talking with the right guy for this.
Three?
So you're definitely talking with the...
Yeah, you're talking to the right person. All right, so we're talking about the features. BTRFS understands encoders, data encoders. Currently we have compression, deduplication and encryptions. And deduplication and encryption are under development. It's not quite stable yet. However, compression is quite stable.
Deduplication at the moment is
Yeah, whether you
it's
consider
a batch process, correct? You
Correct.
can do it, but it doesn't do it on the fly, whereas the reason it's in buckets is because the aim is actually to do it on the fly. Is that correct?
correct. We have both the versions as of now.
Oh, you do?
It's a very old version is like on the fly, and there is a one more version of deduplication which is offline.
Okay.
So, yeah, data encoders are quite useful, and compression, of course, is useful. Compression is quite intelligent in its own. Suppose not all files are compressible, and after the compress, the size of the files may be more than the size of the file which is not compressed. So BTRFS internally will take care of it automatically. And if he finds that after compression the file is bigger than before the compression, then it doesn't compress at all. However, certain users would like to have a consistency in how the file system is being handled. So for that purpose, there is also a command. There is also a tool. There is also an option to force the compression on all the files, irrespective of whether it is compressed well or not. And coming to the encryption, recently I have submitted a patch to bring the support for the BTRFS. There are a lot of things planned for this. As of now, what it does is it does only the symmetrical compression, symmetrical encryption. That means you have a password to encrypt the files, and you use the same password to decrypt the files. This is symmetrical encryption, and however, a word of caution is that it's quite unstable. I know there are so many bugs with it.
So, specific questions. When you say unstable, is it unstable in the sense that if I install it today, I might need to rebuild my FS next week because it changes, or is it unstable in the sense that if I install it today, it might corrupt my file system?
Sorry, I confused you. I think what I mean is like unstable in the sense like it can panic, or
Okay.
It may deem your system unstable. However, the file system layout as such is quite stable.
Okay.
All right, this is a simple example about the compression, and this is the option that I was talking about. If you want each and every files to be compressed, then this is the mount option that you could use. However, not everyone would agree that they need a compression on the whole file system. Rather, some people would say that, okay, I would need a compression only on certain sub-volumes or a snapshot or anything like that. So in that case, like you can use the property command and set the compression property on a specific sub-volume, and that will ensure that it will compress only the files data under that sub-volume and nothing else. Okay, this is the few set of commands used for the encryption. And so for encryption, as of now, you must apply it on an empty subvolume. However, I'm planning to remove that kind of a restriction in the long run. So when you're creating a file system, when you're creating a subvolume, you mention with an -e option. So what it would ensure is to ask for a password and make sure that all the file data are encrypted with your key. And suppose at any point in time, if you want to say I want to log out of this subvolume, then you would say -k out, and it would revoke the key using the well-known keyctl commands. You could either use this command or directly go and use the keyctl command to revoke the key. To understand which key this subvolume is associated with, you can use this. I didn't show that command here. You could use subvolume show command, and that will tell you like what's the key tag that this subvolume is using.
So is
Yeah,
it
please.
just lux in that you have like the key that I type in is not really the key. It's only the key to the key. And
Correct. Exactly, yeah. Yeah, it's key to the key, yeah.
Okay.
It generates its key and based on the key what you provide. As of now, the encryption supports only one type of algorithm, AES. However, there is a very provision to add any number of algorithms that you wish for in the long run. One of the interesting feature that is planned is to have an asymmetrical encryption. That is, you use private and public keys. This is quite useful when you're doing a remote backup and you want to ensure that your data is encrypted when it is going through the internet. That means like without decrypting here, you can take the file contents and send it across the network to take a remote backup. All right, it's an sorry, go ahead.
Sorry, this is interesting. So how is that, if I want to do remote backup, how is that different from just sending everything except the key block? Like, what does the asymmetrical encryption time mean? Or is it not block? It's still block by block, right? So,
Exactly, yeah.
So I send out all the blocks which are newer than the latest backup, right? That's what send and receive does, right?
Correct. Correct.
So where does encryption factor into that? Because the blocks you're sending are the encrypted blocks, right?
No, without the encryption, it won't be encrypted blocks. If a subvolume is not encrypted, then
Right, but if it's encrypted, it's the blocks that we send are
Okay,
the
okay.
things that are on the disk, right?
correct. I understand your question. So suppose like if you have logged in, then the diff what you generate would be a human readable diff. It's a decrypted diff. However, what is planned is like if you log out or do not provide a private key, then whatever you read would be an encrypted data which can be used directly to send it to a remote server. Features are never ending with respect to BTRFS, and we like it. Scrub, as I mentioned, like we have the checksum for both metadata and data. And suppose if you suspect something, some of the disk is acting flaky and it may have corrupted certain data and files, what you could do is like you can run a scrub command, BTRFS scrub, and it would scrub all the files and directories and to find out if there are any silent data corruption. If it is so, then it would automatically fix it. The BTRFS is SSD aware and optimized, and not much there about it as of now. Only thing what it does is that what it is done for a normal hard disk which needs a seek pattern, we don't need that for the SSD, so we don't put much more CPU efforts in doing that. We would avoid that and just do the read and write for the SSDs if it is SSDs. BTRFS as such is highly scalable, and the limitations are quite high, and you could have 2 to the power of 64 subvolumes, and each subvolume can have again 2 to the power of 64 inodes, and that makes it around 2 to the power of 128 total files that you could have in a BTRFS tree. And it could address up to 16 exabytes of storage, and this is one of the least known feature, but it's quite interesting with respect to what potentially it can do. It's called seed and sprout. I have an example on this, and what you could potentially do is you could install an OS without reboot. FSCK can be redundant. It's not yet there, but at some point in time, I think we can be there, or we should be there. There is a BTRFS convert tool which can convert ext4 file system into BTRFS. It doesn't delete any ext4 data as such. So if you are not comfortable with the BTRFS, then there is always choice to roll back.
Stable is that conversion. I tried that once, then I had a corrupt BTRFS file system that didn't work.
When was that?
That might have been a year ago, but let's see, that's Fedora 21, I think, or something like that.
I believe it's quite stable nowadays. Of course, there can be certain bugs. I do remember following that in the mailing list, but it was very, very long time back, if I remember correctly. And also that points out that what version Fedora is shipping.
Yes.
So if you have more latest BTRFS kernel, then probably it's better to use. Sorry.
Kernel panic or power loss while I converting my file system.
Converting your file system. You mean to say when you are using BTRFS convert and if there is a power loss on the system, then what will happen, is it?
Yeah. The origin DSP4 is okay or not?
It will be still okay, I think. I'm not too sure. Like here it's I'm not too sure at what stage the conversion will be, and if you have a question is if you have a power loss in between. So predominantly it will depend on like what stage the conversion is. So looks like you had such a situation earlier. Did you?
Well, of course, the thing to do is do a backup before converting in case.
Yeah, just in case. All right. So as we know, like everything is managed in the tree, and there is no separate allocations for the files. Oh, please. Oh. All right. BTRFS works very, very efficiently for small files. It packs metadata and data, both of them very together. And so the performance with the small files are quite awesome. There is a quota feature as well, and there are some updates to it very recently. That's the reason it's in the bracket. And I have also implemented the hot spare and the auto replace feature, I think it was last year. That feature was an enterprise requirement. This was a feature that I was talking about, seed and sprout. So forget about this. Sorry, go ahead. Sorry, you have a question? All right. Forget about this. So here I'm trying to create a BTRFS file system which is read-only, and there is a BTRFS tune command with where you can create an read-only BTRFS file system. So here you mount it, and what you do is you add your root file system, root device to it, and once you do it, that means it creates one more file system on this device. However, this device will have all the data, the original data or the original ISO image or whatever it is. Then after your configuration and everything, if you find everything is okay, what you do is like you just delete the original device. You remount with the read-write option and delete the device. So all the data will be written to the device which you wanted to make it as a root device, that is SDE in this example. So you have a live system which doesn't need a reboot as such. I haven't tried this, but I'm sure it should work. If it doesn't work, then there are things to fix. Yeah, please drop me an email or in the mailing list, and people are quite active in this mailing list. They fix quite a lot of things. Okay, internals, and we all know B+tree. All the data is at the leaf, and IBM Research Ohad Rodi suggested a new type of a modification to this tree, where we could snapshot, create a copy and write, and snapshot the trees using his algorithm. And the implementation within the Btrfs is quite simple, and it just uses block header keys and the item. And yeah, there are only two things, nodes and leaves, and nodes point to the other nodes, and ultimately it would reach the leaf where the actual data are. And in within BTRFS, everything is in tree, binary trees. And when you create a new BTRFS, immediately you will have I think 4 to 5 types of trees, like extents tree, checksum tree, chunk tree, and this is mainly for the group profiles and rates stuff, and the device tree. Okay, stability part, I think this is the key concern of most of the users. Of course, the file system as such is quite stable with RAID 1.0 and snapshot send receives. These are the features, stable features, including compression. And there are certain known issues with the space management, especially with the type of read and write, where you would do read, modify, write kind of operations, just like a database workload. And of course, quota, encryption, pool management, these are under development, but it's stable enough to use it. But once in a while, we do make major updates to this. Okay, there is an auto defrag. Because it would help in certain read, modify, write workloads, and if it's causing too much of space issue, then there is an option to turn off the copy and write as well.
That can be just applied to a sub-volume, correct? Turn off copy and write.
Yes, you could do that per sub-volume as well.
Yeah. So no. If you want to keep a database file on BTRFS, it's better to turn off copy and write.
That's also a question about in terms of performance for databases and file-based virtual machines, which doing more BTRFS volumes because of the fragmentation issues and stuff. Still recommended to copy and write.
Correct. Yeah. And yeah, since I've worked on ZFS also, like that was one of the solutions even for ZFS.
I thought there was talk at one stage about for databases to be able to integrate into the file system. So instead of creating a file, they would actually just use BTRFS to do all the record management, so that there was no file to be dealt with. So, and because they're doing, the problem is the database is doing a lot of stuff that BTRFS is doing.
Correct.
So why should they do it? So
Yeah.
is that still the plan, or?
I don't know about that, but yes, that is one of the idea that was there.
I think there
It
was
all-
a set piece of that.
Yeah.
Something Seth was using something like that. Or going to.
Yeah. Yeah, that potentially Btrfs can do it quite well with that. Sorry, did I address you?
Yeah, I just trying to find more about, especially the file-based virtual machines. And if I want to,
Yeah.
because you kind of want to copy and write, that's the whole point of the system.
Correct.
So running the auto defrag on a live system, is that okay? Or would you sort of bring the virtual machine down, virtual machine down before you defrag the file or something? Can it be done online?
Defragmentation?
Yeah.
Is that defrag tool?
No, I was saying if I'm running a VM on the on the file system, and I want to defrag that virtual file system.
Just the file is.
The virtual machine.
Yeah, the host is for BTRFS.
Yeah.
The virtual machine can have.
Correct.
Yeah, so on the host I'm running the defrag.
Yeah.
Can you do that on like a live system? Like let's say there is a database sitting on a BTRFS file system and you're having performance problems where you need to defrag it. Can you do that without taking the database offline?
Yes, you could do. Yeah. I mean, you mean to say the virtual machine without stopping it, can you run the defrag? Is that your question? Yes, you could. Yeah.
Although also, yeah, so, there is the option, of course, at mount time for option defrag, but you wouldn't want that for your VMs because it will increase the kind of write penalty quite a lot.
Yeah, these are some references, and thank you. It's nice to have you all here.